So I'm sure anyone watching this is pretty familiar with the neck pain that you get after a long time staring at a computer screen or a phone, and oftentimes it's because we're extending our neck a lot further than we should be. So when I'm standing like this, I have a 0-degree angle between my neck and my head. But as I move my angle out further and further, we're going to see that my rotational force, also called torque, is going to get higher and higher. So let's take a look at this guy right here. As we know, there's going to be gravity working down on him, and the magnitude of this force downwards is the gravity multiplied by the mass of his head. Its value is quantified by T equals R times the component of force parallel to the plane in which we're working. So let's take a look at this guy right here. So my little side profile man, as I like to call him, as we know that there's going to be gravity working down on him in the y direction, and this is going to be a force that is equal to mg, or the mass of his head, times the gravitational force pushing it downward. We're also going to see that we need an R value, and this R value is the shortest distance between the center of mass and the point of pivot in his neck. So this right here is our R value, and we can say it's maybe 15 centimeters. All right, so if he's standing straight up like he is, there's not any angle here. Right here, there's the 0-degree angle. Right here, we're seeing a little bit more of an angle between my point of pivot and the center of mass of my head. So when we calculate his torque, this value right here is going to be 0. So we're going to see this man right here with this perfect posture has a torque of 0. And torque is measured in joules, or Newton meters. So that's the amount of work that he has to do. And so your neck having to do 0 work for rotational force is definitely good for your spine, because you're not putting on any extra newtons or force that your spine is not going to thank you for in the future. And this right here is 30 degrees. So if we draw out our torque vector equation, T equals R times the force parallel to our plane in which we're looking. So we're going to see that the torque here is equal to R. So let's say that it's 0.15 meters. That might be a little off. I don't know how long a neck would be. I didn't measure, sorry. But 0.15 meters times this right here. So remember, we still have gravity acting downwards. No matter what incline we're at, it's always going to act exactly downwards. So the average mass of a human head is going to be around 5 kilograms. So torque is equal to our R value of 0.15 meters times mg, which would be 9.8 meters per second squared, times our mass, which we're going to say is around 5 kilograms, times, this is where our theta comes in right here. So we want to multiply this by the cosine of 60. Remember, this is 90 degrees, so we're going to multiply by the cosine of 90 minus 30. So when we calculate this out, we're going to get 0.15 times 9.8 times, 5 times the cosine of 60. Our torque is going to be around 3.675 joules, or Newton meters. So let's see the increase if we increase this from 30 to 60. Okay, so we've increased this angle by another 30 degrees, so we're double the angle right now. This guy's going to be some serious pain, so let's calculate his torque to see how much work his neck is having to do right now. So the torque, we're going to keep the value for R the same, just to show that it really is the angle that's at work here. Our force, again, is going to be mg, so 9.8 times gravity, or times mass, which again, we're gonna use that 5 kilograms. This is meters per second squared. Times, and here we're gonna have we're gonna have the cosine of 30. Now you might be kind of confused on why we're doing the cosine of 30. Again, we're gonna do 90 minus 60. So if we calculate this out, we're gonna expect a value higher than 3.65 or 3.675 because that's what we got when it was at 30 degrees. Now we're at a higher angle, so let's see if that affects it so much. Double the angle, we're gonna about double the amount of torque we're gonna see. Instead of the 3.675 joules, you're next having to do 6.365 joules of work. So this clearly illustrates that keeping your head at that 0 degree angle in line with your neck is very important because your pivotal joints might be okay right now as you're young, but as you grow older, it really can have a strain on you, and you don't want to have a bad back when you're older. So just remember, when you're texting, phone up. When you're studying, head back, and you should be okay. And remember that physics really does matter when it comes to your health.